Enceladus. Saturn's ocean-covered moon spews water into space non-stop. The liquid leaves the insides of the moon through fractures in its icy crust. In the mid-2000s, the Cassini spacecraft analyzed the composition of these jets and spotted molecules that included ammonia and carbon dioxide. Both compounds are crucial for the existence of life on Earth. But recently, scientists have made another analysis of the Cassini samples, and this study has revealed a great chemical diversity of Enceladus. It makes this small icy moon one of the top candidates for finding life in the solar system. In an attempt to find out the true chemical makeup of the moon, researchers at NASA examined the data collected in 2001 and 2012 again. All this information was gathered by NASA's Cassini-Huygens mission. It flew a spacecraft through the impressive water plumes of Saturn's moon many times. The samples were analyzed by a special instrument identifying compounds by their molecular weight. This instrument is called a mass spectrometer, and Cassini had one on board. The initial analysis showed that the jets contained 5 types of molecules: water, carbon dioxide, ammonia, methane, and molecular hydrogen. But later, experts spotted a few bigger and heavier compounds, including ethane and hydrogen cyanide, as well as traces of methanol. The initial Cassini analysis didn't show these compounds because the equipment on board the spacecraft wasn't capable of identifying them. That's why it came as a surprise that Saturn's small moons could be so chemically active and able to produce heavy molecules. Together with previously found components like water and ammonia, the newly discovered molecules might serve as fuel and building blocks for microbes, which in turn means that they could probably support an independent origin of life. It's one of the reasons why, after the discovery of its oceans, Enceladus has been one of the main targets in the search for extraterrestrial life. The molecules might be mixing together through the hydrothermal activity on the moon's seafloor, creating a habitable environment where life could appear. So far, scientists haven't found any evidence that could indicate that such a process has actually been going on. Plus, no one knows yet how the erupting water makes its way through the icy shell of the moon. Still, the most recent findings might help ongoing and planned missions exploring other ocean worlds similar to Enceladus. One of such worlds is Jupiter's watery moon Europa. This place is likely to have the same properties as Saturn's moon. Hopefully, we'll get the answers to these questions soon, with the help of the European Space Agency's Jupiter Icy Moons Explorer spacecraft. At the moment, it's on its way to the Jupiter system. But then another question might arise. If we found the conditions where life can originate and even thrive, can't this fact already be proof of the existence of extraterrestrial life? Doesn't it mean that life must be abundant in the universe? Then why haven't we come across other species yet? The answers to this paradox vary from optimistic to downright terrifying. It might be because we haven't been looking long enough, or maybe we haven't been emitting enough traceable signatures for other civilizations to find us, or perhaps no species have ever made it to the point where they could come into contact with other civilizations. There's also the frightening dark forest hypothesis. It's a theory claiming that loads of alien civilizations exist throughout the universe, but they are all silent and hostile. They try to maintain their undetectability for fear of getting destroyed by another unfriendly species. So, following this hypothesis, we can presume that any spacefaring civilization must view other intelligent forms of life as an inevitable threat, and the best course of action is to hide its existence altogether. This makes the cosmic electromagnetic spectrum eerily quiet, with no evidence of any intelligent extraterrestrial life. This way, the universe can be compared to a dark forest filled with armed hunters wandering among trees like ghosts.
Consider now
Enceladus,
Saturn's icy moon, one of the most promising places to look for life outside Earth. Scientists have just detected the last one of the 6 necessary ingredients for its formation: phosphorus. This rarest element has been discovered in an ocean on Enceladus. This rare element helps make the soil fertile on Earth. But the concentration of this mineral in the hidden seas on the distant moon might be from 100 to 1,000 times greater than in the oceans of our home planet. It might be because
Enceladus.
ocean is rich in carbonates, just like soda water, and this soda water is likely to dissolve the phosphates in the moon's rocks. The new discovery also suggests that on other icy moons of Saturn, like Titan, the waters may be loaded with phosphorus too. Why are scientists so excited about this mineral? Well, phosphates, which are compounds that contain phosphorus, are crucial components of life on Earth. DNA, RNA, and cell membranes contain them. But among those 6 elements required for life, which are carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, phosphorus is the least common. In 2004, the Cassini space probe entered the dust from the second outermost ring of Saturn, called the E-ring. It's made up of ice grains in Cetulus ejects. And while studying these ice grains examined by Cassini's cosmic dust analyzer, researchers have detected phosphorus.
Enceladus.
Is the 6th largest moon of Saturn. It's not really large, only 314 miles across. This makes the space body small enough to fit inside Arizona. We should try that sometime. Interestingly, when the Cassini space probe first arrived at Saturn, astronomers thought that
Enceladus.
it was going to be a frozen ball of ice. But then, surprise, surprise, they spotted plumes of icy particles and water vapor erupting from geysers on the moon's surface. It became clear that there was a global ocean between the moon's rocky core and its icy shell. The same researchers previously discovered that Saturn's moon might be home to complex organic molecules, too. Before, scientists thought phosphates could be trapped within the rocky cores of
Enceladus.
and similar worlds. That's why the newest works, which hint that phosphates might also be abundant in the ocean, came as a surprise. Researchers examined 305 ice grains from Saturn's E-ring and found out that 9 of them contained phosphates. And these results were clear and unmistakable. And it's very important because some time ago, phosphine, a compound of hydrogen and phosphorus, was believed to exist in the clouds of Venus. But no one has managed to find any evidence to support this theory. On
Enceladus.
there's no controversy, and phosphates do exist there. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick, but it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking mission to access such a deep environment. On the bright side, as we are, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are 2 great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Then we've got Titan, Saturn's largest moon. It's smaller and has lighter gravity than Earth, but it still reminds us of our planet. Like on Earth, nitrogen dominates its atmosphere. Titan is the only other world in our solar system with lakes and rivers. These water bodies are made of hydrocarbons, methane, and ethane. There's also a subsurface ocean of water, but it's located very deep down, and no one has figured out yet if this ocean makes contact with anything under the surface. If it does, it could provide fuel for life after mixing with complex chemistry on the surface. But
Enceladus.
and the other icy moons aren't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example, by cattle digesting food and emitting, gas. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet. and it happened 600 times faster than the researchers' model accounted for. The question? What or who generated the gas, and where did it go? Another Martian mystery is microbes that might be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Ooh, that's a long shelf life. This means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the frozen temperature is similar to that of dry ice. In other words, it's deeply frozen. Let it go. And still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Anyway, if we don't find life outside Earth in our solar system, we could probably look for it on exoplanets, which is what planets outside our star system are called. Some of them look very promising. The closest to Earth exoplanet is Proxima Centauri b. It's a mere 4.2 light-years away from Earth. Recently, astronomers have found out that this world might resemble Earth even more than they previously thought. It's just 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri b is in the middle of the star's habitable zone. This means that the chances of liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. One of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere, is traveling too close to its star, and completes one orbit within 11 Earth days. The radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. Gliese 832c is 16.2 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. This exoplanet is 5 times as massive as Earth and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this star is a red dwarf, much cooler and dimmer than the Sun, Gliese 832c gets as much light and heat as our planet. At the same time, it's still unclear if it's similar to Earth. The planet probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that Gliese 832c is more likely to resemble scorching hot Venus rather than the relatively cool Earth. Hey, I'm cool with that.
Titan is Saturn's largest moon. It's also the second largest moon in the solar system, after Jupiter and Ganymede. And it's the only moon with clouds and a dense planet-like atmosphere. But the coolest thing? This moon might help us understand how life appeared on Earth, and for us to understand whether you like such videos or not. Please put a like and subscribe to the channel. Your support is important to us. Thank you. Astronomers say that the conditions on Titan might be almost the same as those on Earth in its early years. The only significant difference is that, being closer to the Sun, Earth has always been warmer. Titan is surrounded by an orange haze, which had kept the moon's surface a mystery for astronomers up until 2004. That's when the Cassini mission arrived there. Now we know that Titan's atmosphere extends about 370 miles high. That's a lot higher than the atmosphere of our planet. Because of this atmosphere, Titan was believed to be the largest moon in the solar system for a long time. But the most exciting fact about Titan's atmosphere is that it's full of organic compounds. If they were discovered on our planet, they would definitely mean life. Now, the atmosphere of Titan is mostly nitrogen mixed with a bit of methane and other organic compounds, which form when sunlight destroys methane. But if sunlight keeps destroying methane, how does this gas appear in the atmosphere again and again? On Earth, it's life itself that restores the supply of methane, since it's a byproduct of the metabolism of many organisms. So, can we conclude there's life on Titan? This distant moon isn't the most pleasant place to settle down. It's too cold for liquid water to exist on its surface. And still, Titan has rivers, seas, and lakes of liquid hydrocarbons, such as methane and ethane. The largest of them are hundreds of feet deep and hundreds of miles wide. Beneath the thick crust of the moon, there is a more liquid ocean consisting primarily of water rather than methane. After a series of laboratory simulations, scientists concluded that there might be enough organic material on Titan for a chemical evolution to begin. It could be similar to the one that started life on Earth. But for that to happen, there must be liquid water on the moon for longer periods of time than what we observe now. And still, it might be another proof supporting the idea of a liquid water ocean under the frozen isolation layer. If it was true, Titan's subsurface ocean could turn out to be a place harboring life as we know it. Meanwhile, its lakes and seas of liquid hydrocarbons could have forms of life with different chemistry than what we're used to. Or there may be no life at all. After all, the temperature on the surface of Saturn's moon is about 290 OF. These conditions are far from comfortable for almost any life form. According to one theory, a meteorite impact that occurred a long time ago could have provided enough heat to liquefy water for around a few hundred or thousand years. But right now, most experts think that Titan isn't likely to be a place where life thrives, which makes the presence of methane in the moon's atmosphere even more puzzling. Interestingly, Titan might become warmer in the future. You see, 5 to 6 billion years from now, the sun will become a red giant. It will heat up most space objects in our solar system, and Titan will become warmer, 94 OF. This temperature is high enough for stable oceans of a water-ammonia mixture to exist on its surface. With time, the sun's ultraviolet output will decrease, which will enable the greenhouse effect in Titan's upper atmosphere. The combination of these conditions might exist for several 100 million years, creating an environment suitable for the appearance of exotic forms of life. After all, this time was enough for life to evolve on Earth. The only thing that might hinder the process on Titan could be the presence of ammonia. It's likely to cause the same chemical reactions to proceed more slowly.
A team of intrepid scientists have devised an audacious plan to unravel the mysteries of the universe. Their secret weapon? Computation. The very heartbeat of living systems. But what's that? And how will computational zones help us to find extraterrestrial life? Let's find out. In our universe, there are special places called habitable zones. They hold the key to life as we know it. You see, planets are a bit like picky eaters. They have specific preferences for their conditions. Just as we humans need things to survive, planets need their environments to be just right for life to thrive. So, what's the secret recipe for a habitable zone, you ask? It's all about finding that sweet spot where liquid water can exist. Water, as we know, is the magical elixir of life. Planets love to have it flowing or sloshing around on their surfaces. So, we need to find the perfect balance. If a planet is too close to its star, things get toasty, and water evaporates into a sizzling mist. On the flip side, if a planet is too far away, it becomes an icy wasteland, freezing water solid and turning potential life into popsicles. But within that perfect middle zone, also called the Goldilocks zone, temperatures are just right. That means planets have the perfect conditions for life to potentially take root. For a long time, scientists have been looking for planets in these zones. And as of January 2023, we have found a total of 63 potentially habitable exoplanets. However, a recent study has changed our view of where we should look for life. Gone are the days of restricting our search to mere habitable zones. Oh no, we're thinking big. Get ready for the computational zones. These enchanting realms could house life forms we've never even dreamed of encountering before. But what exactly are these computational zones? Well, let's see. When scientists search for life in the universe, they usually look for things similar to what we have here on Earth. They imagine creatures living on a planet's surface at just the right distance from their star and using water for important chemical reactions. But what if life can be much more diverse and fascinating than that? Imagine life using different liquids instead of water. Picture life hiding deep underground in icy moons. It's even possible that life doesn't need a star at all. And there might be biological systems that are different from our idea of life in general, but still alive in their own unique way. That's why two clever researchers have come up with a new idea. They want to change how we think about the places where life could exist. Instead of focusing on habitable zones, they suggest looking for computational zones. Think of these computational zones as special kitchens, where the secret recipe for life is being prepared. To make this recipe work, we need three key things. First, we need a variety of special ingredients, like different chemicals. Just like a chef needs various spices and flavors to create a delicious dish, life needs different chemicals for its calculations. Second, we need a source of energy, like sunlight or heat from hydrothermal vents. This energy powers the cooking process, just like heat powers a chef's stove. Lastly, we need a dedicated space, like a kitchen counter, where all the calculations can happen. It's the place where the ingredients come together and amazing things start to occur. In our case, it was our solar system and our planet Earth. Basically, computational zones should have three things: some chemicals, source of energy, and space. This makes a pretty wide sample, isn't it? By focusing on computational zones, the researchers believe we have a better chance of finding signs of life. These zones could lead us to amazing discoveries and show us that life in the universe is much more creative and diverse than we ever imagined. And here's the real mind-boggler. This idea also leads us to think about technology. Yes, AI and stuff. Just as we humans create and use technology, could life itself create its own technological marvels? Life could be biological, digital, or even something completely different. Computational zones give us a fresh way of thinking outside the box and get creative. Now here's another twist in all this research. Turns out that life might be much closer than we think, as if in our own solar system. It turns out that the insides of icy moons, like Europa or Enceladus, answer to all these conditions. They're just as fascinating as the surface of rocky planets. It's like realizing that hidden treasure lies right beneath our feet. Europa is Jupiter's icy moon, which is as old as our Earth. It looks like a half-sphere with a bright, icy appearance, an off-white color with a hint of blue. Mysterious dark lines stretch across the moon, forming patterns. It lacks towering mountains or deep basins, but instead showcases dark ridges, grooves, and long streaks. As you move toward the bottom of the image, Europa fades into darkness, leaving us curious about what lies beyond. But the most important thing about Europa is that it's a fascinating candidate for life. First of all, this moon has liquid water in abundance. Scientists believe that there might be an entire salty ocean beneath its icy surface. There might be twice as much water as all the oceans on Earth combined, but life needs more than just water to exist. It requires certain chemical elements like carbon, hydrogen, oxygen, and so on. They're like the building blocks of life. These elements are found throughout the universe and make up a whopping 98% of living matter on Earth. And Europa is believed to have a lot of all these elements too. Perhaps they were brought there in the distant past after a collision with asteroids and comets. Although it's pretty cool that we found organic molecules on Europa, it doesn't automatically mean they are linked to life. These molecules can be created in non-living processes as well, but they still give us some very important clues. And finally, energy. It's like fuel for life. Just like we need food to keep going, all living things need energy to survive. On Earth, plants get their energy from the sun through a cool process called photosynthesis. Plants turn sunlight into food, and when animals eat those plants, they get energy too. But the kind of life that might live on Europa can't rely on sunlight. Europa is covered in a thick layer of ice, so there's no sunshine reaching its surface. Instead, life on Europa would have to find another way to get energy. And that way is through chemical reactions. Europa's surface gets showered by radiation from Jupiter, which is not so great for living things up there, to say the least. However, this radiation can actually be helpful. It helps to create oxygen and hydrogen in Europa's atmosphere. But that's not all. As Europa orbits around Jupiter, it gets flexed and squeezed by the planet's gravity. This flexing generates heat. just like how bending a paperclip can make it warm. The heat from this process can provide energy for life too. So as you can see, Europa's potential life forms have to get creative. But this little moon still has a very high chance of supporting life. It's a fascinating and mysterious world out there. And Saturn's moon Enceladus is also an exciting place where life could thrive. But detecting this life is no easy task. The moon is covered by a thick ice shell with a super deep ocean beneath. Even here on Earth, that would be a huge challenge, let alone on a moon halfway across the solar system. Enceladus is nothing like Earth, so don't expect to find cows and butterflies there. But it would have its own unique ecosystem. Some organisms that rely on chemical reactions for energy, although life on Enceladus, if it exists, might be extremely scarce. But regardless, we should keep exploring it. Any findings would be helpful for our future missions. All these new discoveries open new possibilities and fuel our curiosity about life beyond our planet. Who knows what exciting discoveries await us in the vast universe? Let's keep exploring and find out. Ah, well-deserved vacay, finally. This time you're off to see something new. It's an ocean on one of the Uranus's moons. Alright, just kidding. This destination is not a vacation spot yet. But yeah, there are definitely some impressive oceans out there. Hey, don't say you thought oceans can only be found on Earth. But before diving into Uranus Moon's oceans, let's talk about Uranus itself first. The 7th planet from the Sun, and the coolest cat in the solar system. It's got 27 moons, and 4 of them might technically have oceans. That's more than most people have, friends. All these moons are like Uranus's mini-me's. They tilt at the same crazy angle as their parent planet, 98 degrees to be exact. And Uranus is so unique that it orbits the Sun on its side. That means its equator is almost at a right angle to its orbit. Talk about rebellious. But why is Uranus like this? Well, some astronomers reckon it's because it got knocked on its side by a massive collision with another planet. And that impact might have actually created Uranus's moons. Fun fact, those moons have pretty particular names. Instead of mythical figures, most of them are named after Shakespearean characters. I mean, who needs Zeus when you've got Juliet and Desdemona? Discovering these moons isn't easy. They're super dark and located billions of miles away from the Sun. It's like trying to find a needle in a haystack, except the needle is smaller than your pinky finger. These 27 satellites are divided into 3 groups: 13 inner moons, 5 major moons, and 9 irregular moons. The irregular ones are rebels with retrograde orbits, while the others are prograde and go with the flow of Uranus. The big boys are Miranda, Ariel, Umbriel, Titania, and Oberon, and they're all in Uranus's equatorial plane and are big enough to be round. They've got craters and canyons and cliffs. Oh my. These moons also formed from a giant impact that tilted Uranus on its axis. That's why they're all tilted too. And because of that tilt, they have crazy seasonal cycles just like Uranus itself. But we haven't found all of Uranus's moons yet. The little irregular ones are sneaky and hard to detect, so who knows how many more there could be. But let's talk about the really cool stuff, what these moons are made of. We're not entirely sure, but we think they're made of rock and ice. Miranda is the most icy one, while the inner moons are probably just dusty. And the ones beyond Oberon's orbit, they're likely captured asteroids that could be rocky, or icy, or who knows what. But here's what really sets Uranus's moons apart. They're all tilted together with Uranus. That's wild. Exploring these moons could teach us so much about how ocean worlds form and stay active. Titania is the biggest moon of Uranus, but it's still less than half the size of Earth's moon with a diameter of about 1,000 miles. It's also the 8th heaviest moon in the whole solar system. They named it after the fairy queen in A Midsummer Night's Dream. Titania's color is gray, and it has some shiny patches that scientists think are frost. It's made up of a mix of ice and rock, just like all the other moons close to Uranus. Oberon is the next biggest moon of Uranus, named after the fairy king in Shakespeare's play. It's almost the same size as Titania, and also has a half-ice/half-rock composition. But Oberon's surface is way more cratered than the other Uranian moons. Umbriel and Ariel are the 3rd and 4th largest moons of Uranus, with diameters of 726 miles and 718 miles respectively. Umbriel is named after a bad spirit in an old poem, and it's the darkest of all Uranus's big moons. It only reflects 16% of the light that hits it. Scientists don't know why it's so dark, but they think a bright ring around a crater might be caused by frost deposits. Ariel is the brightest of all Uranus's big moons, and it reflects over a third of the light that hits it. It's named after characters in both Pope's poem and Shakespeare's play. Ariel looks like the youngest moon because it only has a few small craters from recent collisions. Miranda is the smallest of all these big moons with a diameter of about 292 miles. NASA says it looks like it's made up of parts from different bodies, like a Frankenstein's monster. Miranda has 3 big features called coronae that are unique to it. They're lightly cratered with ridges and valleys, and they're separated from older and more heavily cratered parts of Miranda by sharp boundaries. It also has giant canyons that are up to 12 times deeper than the Grand Canyon. Scientists don't know why Miranda has such different features, but one theory is that it got smashed apart by a huge collision and then put back together all wonky. All these big Uranian moons are stuck facing Uranus all the time, just like Earth's moon. Uranus has got some seriously dope features, but the ring system is where it's at. And get this, the ice giant's moons actually have a hand in shaping those rings. Uranus has 13 inner moons and 13 faint rings, and they're all connected like one big cosmic family. Cordelia and Ophelia are like the guardians of the outermost ring, Epsilon. These 2 shepherd moons keep all the particles together, with Cordelia being the closest to Uranus's surface. But here's the kicker. There are at least 8 other tiny satellites hanging around in that area, making things super crowded. NASA is still scratching their heads trying to figure out how they don't all crash into each other. The inner moons are half ice and half rock, but we don't know much about the outer ones. NASA thinks they might just be asteroids that got caught up in Uranus's gravitational pull. Either way, Uranus and its moon squad are definitely out of this world. Apparently, Uranus's moons might have salty oceans hiding under their frozen surfaces, and the farthest ones from Uranus, Titania, and Oberon could have oceans that are 30 miles deep. That's deeper than the Mariana Trench, 7 miles. But even Ariel and Umbriel might have oceans around 19 miles deep. NASA used some fancy computer modeling and revisited data from their Voyager 2 spacecraft, launched way back in 1977, to figure out the makeup and structure of these moons. They found that Titania is huge enough to keep its internal heat and prevent its ocean from freezing. But get this, the other moons might have a chance at having warm oceans too. The researchers discovered potential sources of heat in the moon's rocky mantles that could release hot liquid and keep the oceans warm. And guess what? The oceans might even be warm enough to theoretically support life. The study also found that chlorides and ammonia are likely abundant in the oceans of these moons. Ammonia acts as antifreeze, and salts in the water could also help maintain the ocean's temperature. Now you might be thinking, how can these icy moons have liquid water? Well, turns out their internal heat and some chemicals could make it happen. For example, a study revealed that chlorides and ammonia are likely abundant in the oceans of these moons. Ammonia acts as an antifreeze, and salts in the water could also help maintain the ocean's temperature. And if these moons really do have oceans, that means there could be other ocean worlds in our solar system and beyond. But don't get too excited. These oceans are pretty salty. About 150 grams of salt for every liter of water. That may not be saltier than Utah's Great Salt Lake, but still. As for Uranus's 5th biggest moon, Miranda, welp, it might have had an ocean at some point, but it probably froze over pretty quickly. Poor little guy. Anyway, NASA is thinking about sending a mission to Uranus to learn more about these icy giants and their moons. They're calling it the Uranus Orbiter and Probe, UOP. Sounds like a party to me. So yeah, technically there might be not 4 but even 5 oceans, but there's still much to learn and explore. Imagine a still, frozen world. It's ancient, about 4.5 billion years old. It's barely heated by the rays of the sun and covered with a thick layer of ice. This world is smaller than our moon, but a bit larger than Pluto. Its name is Europa, the 6th satellite of Jupiter and one of the biggest moons in the solar system. But the coolest thing about this faraway place, it might host life. Astronomers consider Europa one of the most promising places in the solar system to search for new life forms. All because this moon has a huge saltwater ocean with a depth of 40 to 100 miles. Yes, it is hidden under a layer of ice that is estimated to be from 10 to 20 miles thick. But it is still potentially habitable. Astronomers claim that plumes of water erupt from cracks in the ice shell and release the contents of the moon's ocean into space. Of course, it's going to be challenging for any life-seeking missions to access such a deep environment. On the bright side, scientists already have some evidence that there are way shallower pools that probably lie much closer to the surface of the moon. They might be located even less than 1 mile under the ice. And there are two great things about this news. First of all, it boosts the odds of life existing on Europa. And secondly, if it's true, it can make it easier for future missions to find these life forms, if there are any. Interestingly, the new discovery about these shallow pools came about by sheer luck. The scientist leading the research, Riley Kohlberg, accidentally saw a presentation of his colleague, a planetary scientist. That scientist showed a picture of double ridges on the surface of Europa, and Kohlberg remembered that he had seen similar ridges on Earth. But while such formations are rare on our planet, they are way more numerous on Europa. The following studies suggested that the ridges on Jupiter's moon might be the result of a specific cycle, similar to that on Earth. In this cycle, liquid water freezes and then thaws inside an ice sheet, which is a rather high-pressure environment. This causes the sheet to move upward over and over again, creating a two-peaked structure. Or at least that's what happens on Earth. If the processes on Europa are similar, it can prove the presence of shallow waters on the satellite. Of course, the temperature, pressure, and chemistry are very different on Europa. And scientists don't know yet how the ice behaves there. That's why they can't understand how deep or large the water pockets are, or how long they need to refreeze. But what is more or less clear is that such under-ice environments on Europa are very likely to be protected from Jupiter's harsh radiation battering the satellite's surface, which in turn increases the chances of life existing on Europa. Now, can we get back to the fact that the ocean on Europa seems to be salty? Red streaks on the satellite's surface might have this color due to their chemical content. They're likely a frozen mixture of water and salts. This is quite unusual because such a composition doesn't match any known substance here on Earth. As for yellow spots on Europa's surface, those might be caused by the presence of sodium chloride. You know this substance as good old table salt. Scientists tried to recreate the conditions on Europa in a lab. They discovered that by combining water, table salt, freezing temperatures, and high pressure, they could get a new kind of solid crystal. This substance might exist both at the bottom of Europa's ocean and on the moon's surface. But besides this information, researchers are in the dark. Hopefully, we'll find the answers to some of these questions around 2030. That's when a mission called Europa Clipper, which is going to be launched by NASA, will probably reach Europa. The mission is going to have several close flybys and figure out if any form of life can exist on the moon. The European Space Agency's JUICE, which stands for the Jupiter Icy Moons Explorer, is going to visit Europa in the next couple of years too. But Europa isn't the only place in the solar system that might host or once hosted life. In 2003, Mars Express, a spacecraft launched by the European Space Agency, discovered methane in the atmosphere of Mars. On our planet, the biggest part of this gas in the atmosphere is produced by living creatures, for example by cattle digesting food. However, scientists think that methane was stable in the Martian atmosphere for about 300 years. And then, in 2006, the methane almost entirely vanished from the red planet, and it happened 600 times faster than researchers' models accounted for. The question, what or who generated the gas, and where did it go? Another Martian mystery is microbes that may be sleeping beneath the surface of Mars. There, they might have been protected from the harsh radiation coming from space for millions of years. Scientists simulated the conditions on Mars in a lab to check if it could possibly be true. And they were amazed to find out that bacteria could easily survive in such conditions for 280 million years. Which means that if life existed on Mars, we could find the evidence in the planet's subsurface by drilling into the Martian soil. Right now, there is no flowing water on Mars, and cells or spores would simply dry out. Plus, the surface temperature is similar to that of dry ice. In other words, the surface of the planet is deeply frozen, and still, there could be 6 types of bacteria and fungi living underground on the red planet. The most likely of them is nicknamed Conan the Bacterium due to its tough nature. Well, I guess time will show. Now let's move to Venus. In 2020, scientists announced that in the toxic Venusian atmosphere, there was something that might mean the existence of life. Unfortunately, scientists didn't have any evidence, since there was no chance to collect any microbe specimens or snap any pictures of extraterrestrial life. But they claimed that they had discovered a chemical called phosphine there, and it was a big deal. If it wasn't some previously unknown chemistry that was producing this gas, then there could be some kind of microbial life involved in the process. Phosphine is made up of 3 atoms of hydrogen and 1 atom of phosphorus. This gas is toxic to any terrestrial life form that needs oxygen, including us humans. On our planet, phosphine can be found in places with no or little oxygen, for example, marshes and swamps. The gas is created by complex mixtures of bacteria living there. It can also be produced industrially. Come to think of it, phosphine isn't supposed to be in Venus's atmosphere altogether. This gas needs precise pressure and temperature and tons of hydrogen to form. It wouldn't be all that surprising to find it on Saturn or Jupiter, famous gas giants. But on Venus, totally unexpected. There's no way phosphine can be naturally produced on this planet. Tiny amounts of it can be created during volcanic eruptions, lightning storms, minerals blown up to the surface, or meteorites entering Venus's atmosphere, but not as much as astronomers thought they had observed. And it had to make scientists suspicious, but they were too happy about their discovery. They probably thought it meant there could be life on Venus. But even if this gas was created by some mysterious organisms, it would be a big question how they survived on Venus. On our planet, some microbes can thrive in environments with an acidity of 5%, but no more. On Venus, though, clouds are almost entirely made of acid, containing more than 90% of sulfuric acid. The Venusian atmosphere is also 50 times as dry as the driest place on our home planet. And indeed, in 2022, thanks to better and more high-resolution telescopes, it was concluded that there was no phosphine in Venus's atmosphere. Or even if there was, it was a very small amount. So far, we need to look for signs of life further away from Earth.
Wow, the NASA hotline is ringing off the hook. The call center operator is all sweaty from stress. They barely have time to answer the phone, and all the messages they get say the same thing. There's something glowing on the moon. Indeed, hundreds and thousands of amateur astronomers were watching the moon that night. And suddenly, there was a bright light on it, as if someone had lit a powerful spotlight on the surface. Scientists immediately began to look for an explanation to this phenomenon. They first thought it was simply the glow of an airplane flying between the observers and the moon. But then it wouldn't have been seen by so many people from different parts of the world at the same time. The next suspects were the Starlink satellites. Theoretically, one of them could have played a cruel trick on amateur astronomers. They could have mistaken the small satellite's light for a flash of light on the moon. But then again, if the satellite were the culprit of this mess, the flare wouldn't be static, but moving. While some scientists continue to search for an answer to this mystery, others decide to investigate the phenomenon in more detail. For this purpose, they have built a new telescope north of Seville, Spain. The conditions there are quite suitable for observing the moon. The telescope has 2 cameras, controlled remotely from the campus in Germany. If both cameras pick up any unusual phenomenon on the surface of the moon, it will quickly zoom the telescope there to see what's going on. It'll also require advanced artificial intelligence to teach the cameras to distinguish between the unexplained phenomenon on the moon and the light of an airplane, a satellite, or a small meteorite that just entered the Earth's atmosphere. While the telescope is doing its investigation, we already have a theory that may explain the appearance of such bright round flashes on the moon's surface. So, the moon influences the tides of the seas and oceans on Earth with its gravitational force. But the Earth can affect the moon in the same way. Only the force will be 32.5 times stronger. While the moon orbits the Earth, at one point it may be as close to our planet as possible. Then the force of the interaction will be greatest. At this point, tidal forces may force cracks in the surface of the moon to open and release gas from its interior. A powerful jet of gas will lift the lunar dust with it, and what we see as a bright flash through our telescopes is really just a fog of dust, which is round and reflects sunlight well. If you look at it from a distance, it really does look like a flash. As the dust rises, we think there's been a small explosion, and that flash gradually fades as the dust settles down. These things happen all the time on the moon's surface. They're called transient lunar phenomena, and besides lunar flashes, much more mystical and bizarre things have happened. Back in 1178, 5 monks claimed to have seen the moon, being in the shape of a horn, begin to split in two from an upper point. Then fire and sparks began to blaze from the place of separation. It was as if a dragon were spewing flames. In the next moment, the moon began to pulsate and then returned to its calm state. This phenomenon was repeated more than 10 times, and the flames took different shapes each time. When this nightmare was over, the moon turned black. It wasn't until the 20th century that scientists tried to explain the phenomenon. They theorized that a large asteroid collided with the moon at the time, and it was this asteroid that should be blamed for creating the Giordano Bruno crater, 15 Brooklyn bridges wide. But in that case, millions of tons of fragments from the asteroid would have hit the Earth as well, and then people would have seen an incredible meteor shower. It would have been very bright, and the memories of it would definitely have been in the archives. But that didn't happen. Now the phenomenon the monks observed seems questionable. Perhaps they did see an asteroid fall, only it was falling on the Earth itself, and they perceived the light from the burning meteorite as something sinister happening on the moon. Or maybe the monks were simply imagining things. There's no witnesses to this event other than them. Another unusual phenomenon is the blue and red lights on the moon. They can be seen when it's horn-shaped, and this occurs most often in the Aristarchus crater. The flashes come and go very quickly, almost like lightning. In fact, this is electricity. Tidal forces are to blame for this too. They cause mechanical stress to build up in the rocks. This can produce an electric field, which creates the blue flashes that have surprised many amateur astronomers. There can also be starbursts on the moon. We can blame this on meteorites that fall on the surface. Because the moon has no atmosphere, asteroids that approach it don't burn up. Having a lot of weight and speed, they cause an explosion on impact. And here on Earth, we see it as a starburst. For example, on May 13, 1972, there was a meteorite impact of 1,000 tons of TNT near where Apollo 14 landed. If we lived much earlier, we might have witnessed constant bright flashes on the moon's surface. All the craters there are formed by such meteor strikes. So imagine the fireworks that were there years ago. And a lot of those meteorites were even useful too. They brought water with them. Yes, there is water on the moon. NASA confirmed this fact after studies with the SOFIA telescope. It was mounted on an airplane. The observations were made from the upper atmosphere of the Earth. At such an altitude, the dry air allowed the telescope to see even the smallest details. Water might have been in the craters at the poles of the moon. These places have never seen light, and the water there might be encased in ice. But SOFIA found water on the sunlit surface of the moon. Of course, it's only H2O molecules that are present in the dust layers, but that's something. If we manage to collect all this water, we'll get very little of it. In comparison, the Sahara Desert has about 100 times more water than we found on the moon. But an even more unusual phenomenon is happening there right now. The moon is actually rusting, just like a piece of old metal. For rust to appear, We need iron, water, and oxygen. Lunar soil has enough iron in it, and as we've already learned, there's some water too. The last piece of the puzzle is oxygen. Everyone knows there's no atmosphere on the moon, and we can't breathe there, but oxygen is still present. The solar wind brought it there. The wind from our warm star moves at an extremely high speed. It scrapes oxygen from the upper parts of our atmosphere and carries it further through space. Eventually, the wind with the oxygen molecules reaches the moon. Voila! All the ingredients for corrosion are in place, and the iron ore on the surface of the moon begins to take on a reddish hue. If this process goes on long enough, in the distant future, the moon will look like Mars. It will turn orange-red. Yes, the signature color of Mars came exactly from that corrosion that began there thousands and thousands of years ago, when there were rivers and seas with water and an atmosphere with oxygen. Other strange objects that can be seen on the moon were left there by humans. Between 1969 and 1972, 12 people visited there as part of the Apollo program. In all, there were 6 landing sites where the astronauts left a bunch of stuff behind. Besides a couple of dozen satellites and spacecraft that fell or landed softly on the moon, there's a lunar rover, some United States flags, a family photo of one of the astronauts, and even 3 golf balls. And the first 2 people to be on the moon left behind a whole pile of stuff. When they were about to go home, they took a lot of soil samples and rocks with them. And to carry it all away, they had to get rid of everything unnecessary on board the lunar module. The TV camera, the sample collection tools, the science equipment, and even the armrests from the seats. The astronauts stood outside the lunar module for a full 8 minutes and threw out a whole mountain of unnecessary items. If you collect all these objects and debris that we left there by 12 astronauts and put them on the scales, it will show about 199 tons. It's like 3 heavy armored tanks or 3 large passenger planes. Strange, but true. So, Mars has several faces. No, really. Back in 1976, when the Viking 1 orbiter was checking out the red planet, it spotted something interesting. A big structure that looked like a human face. It was in the region called Cydonia. It soon became very popular. A bit later, we also discovered the so-called crown face in Libya Montes. Mars in general has a lot of strange structures on it. In 2022, we spotted a door-like structure there. NASA's Curiosity rover snapped some pictures of a rocky mound called East Cliffs on Mount Sharp. This mound has natural cracks in it, and one of them is about the size of a dog door, like something from an ancient Egyptian tomb. A lot of people hyped that story up. The image was shared widely on social media, making the crack look bigger than it really is. Some people think that it's hinting at extraterrestrial life. But after looking closely, NASA found out that it was just a narrow crack in the rocky terrain. These cracks and gaps are pretty normal in rocky areas, both on Earth and Mars. The crack formed naturally over time, maybe from wind erosion or Mars quakes. Mars is a gold mine of mysterious structures. Recently, we found some strange spiral shapes there. These are giant coils made of lava, and they look like big springs or loops. For years, we weren't sure whether Martian valleys were formed by lava or ice. These lava coils are shedding light on that mystery. Now, thanks to high-resolution images from NASA's Mars Reconnaissance Orbiter, researchers have spotted 269 lava spirals that can't be explained by ice-related activities. What's fascinating is these lava coils are like the ones we see on Earth, like those formed by Hawaiian lava flows. These spirals are so well preserved that they were easily overlooked before. They range from 16 to almost 100 feet wide and are subtle, blending into the dusty Martian landscape. These coils can teach us a lot about Mars's composition, especially its crust and mantle. We still don't know much about those. But Mars isn't the only planet with strange structures on it. For example, Saturn, the gas giant of our solar system, has a fascinating feature at its north pole, a huge hexagon. This is a hexagon-shaped cloud pattern. It's about 9,000 miles long, making it larger than the diameter of Earth. is thought to be a jet stream made of gases moving very fast, at about 200 miles per hour. This hexagon was first spotted by the Voyager mission in the 80s, and later seen up close by the Cassini mission in 2006. The Cassini mission noticed a change in its color from blue to golden over time. There are different ideas about why Saturn has this thing. One theory suggests it forms because of the way winds move at different speeds near Saturn's poles. Similar shapes were created in lab experiments when liquids were rotated at different speeds. Another idea suggests that a slow spinning stream of air, along with Saturn's special weather patterns, might be responsible. In 2020, we found that when storms are surrounded by winds swirling in the opposite direction, they can create a steady hexagon shape. So far, this is the most likely explanation. Saturn also got lucky with the bizarre moons. One of them is called Lapidus. This moon has a weird feature, a huge ridge that wraps around its middle like a giant belt. This basically makes it look like a giant walnut. Where's my nutcracker? This ridge is incredibly tall by our standards, around 8 up to 12 miles high and stretching 124 miles wide. It covers more than 3/4 of the moon's surface and is considered the third largest mountain range in the entire solar system. Now, we don't have a clue about how this enormous ridge formed. It's unlike anything seen on other planets or moons. There's one idea, though. The ridge might be the remnants of a dead moon. Let's say billions of years ago, a colossal impact shattered chunks of material off Lapidus. These pieces circled around the moon, forming a mini-moon or sub-satellite. And over time, the gravitational pull of Lapidus tore this mini-moon apart, creating a ring of debris around it. As the debris from this ring fell back onto Lapidus, it built up the massive ridge we see today. They think this process happened quickly, maybe over centuries. Saturn's gravity didn't interfere because, luckily, Lapidus was quite far away from it. If Lapidus was closer to Saturn, its moon might have been pulled away. But we do need more simulations to see if this theory is true. Titan, another one of Saturn's moons, also has some weird stuff going on in its methane seas. Scientists have spotted these strange bright spots called magic islands that seem to pop up and disappear over time. We have no idea what they are. Titan's atmosphere is packed with complex organic molecules that clump together and fall to its surface like snow. These magic islands might be snow clumps that soak up methane and sink very slowly. But there's a problem. In water, molecules stick together, which is why stuff can float on top of it. But methane is different. It likes to grab onto other molecules, so it makes any solid thing sink immediately. Yet, these magic islands don't sink. There's a theory that these islands might be like sponges made of ice with lots of holes. When pieces of this holy ice come loose from the edge of the lake, they can float on Titan seas for a bit before going down under. There are also other ideas, like bubbles of nitrogen gas or waves caused by wind. We need more research to know for sure. Moons like to be weird. Just look at our own one. In 1971, we found a patch with missing soil on our moon, and it looks like a blue lake. They call this mysterious spot Ina. We first spotted it during the Apollo 15 mission in 1971. Later, the Apollo 17 mission took clearer pictures of it. This spot, shaped like a bluish D letter, is one of the weirdest things on the moon. The color comes from special rocks rich in titanium called basalts. These rocks cover Ina's floor and make it look blue. There are also bluish areas near the edges of the mounds inside Ina. Ina is unique and probably has a long history. It might have had volcanic activity, with mounds that are about 3.5 billion years old. It's similar to the surface age of the volcanic field that surrounds Ina. Now, our moon has its own face, just like those on Mars. There's an area near the moon's south pole that looks like a face, but it's just a bunch of craters and shadows that happen to make an image resembling a face when seen from far away. These craters have been there for billions of years and cover about 16% of the moon's surface. Some of these craters might even have water and ice inside of them. You might be wondering why there are so many faces in our solar system. Well, that's because our brains are wired to recognize faces, even when there aren't any. It's a phenomenon called pareidolia. Our brains try to make sense of shapes, So when we see something that looks a bit like a human, our brain turns it into one because it's familiar. Like when you see a shadow figure on a chair with clothes, or even on Mercury. Some people see shapes like Mickey Mouse. So don't worry, it's not extraterrestrial life. It's our brains that play tricks on us, making us see familiar shapes like faces even where they don't really exist. Now don't get all upset, but the moon is shrinking and getting wrinkled, pretty much like a grape turning into a raisin. That happens because our natural satellite has been retaining its inner heat for over 4 billion years, but its core is gradually cooling down and becoming more dense, like me. Unlike a grape's flexible skin, the moon's surface is pretty brittle. This brittleness causes faults to form where different sections of the crust push up against each other, leading to what scientists call moonquakes. So far, our satellite has shrunk by around 150 feet in circumference. It's such a tiny change that it won't affect the look of eclipses or the phases of the moon. Even tidal cycles won't be affected since the moon's mass hasn't really changed. The shrinking process won't directly affect us down here, but that doesn't mean that all humans are safe. Moonquakes caused by the shrinking process have been a concern for years. During the famous Apollo missions, NASA astronauts left seismometers at different points on the moon. Those are devices capable of identifying seismic activity on the lunar surface with exceptional precision. The equipment was operational for several years, and it managed to capture over 12,000 moonquakes, ranging in magnitudes from 2 to 5. Up until 1977, the team was able to identify 4 distinct types of quakes. Some tremors, like those caused by meteorite impacts, were relatively easy to identify. But the cause of the so-called shallow moonquakes remains a mystery to scientists, and that can be an obstacle to future missions on lunar soil. As the name suggests, shallow moonquakes occur relatively close to the surface, typically between 30 to 135 miles beneath the surface. Recent research suggests that these tremors are triggered by the compression of the moon's surface, leading to the formation of thrust faults, where one surface layer is pushed up over another. This study also discovered where the epicenters of the strongest ones were. It all started in the South Pole region, precisely where we want to settle down. Interest in the lunar South Pole peaked in 2023, when India's Chandrayaan mission successfully landed and deployed a rover to explore the area. NASA also has plans for the same spot. And their ambitious goal is to take astronauts there for the very first time. The Artemis 3 mission, scheduled for 2026, currently has 13 potential landing spots at the South Pole, represented by the blue squares here. One of the options is situated within a geological feature called Deggerloch Rim 2, which is a strategic area for exploration. It might have ice, because parts of it are completely in the dark, but it's close enough to areas that do have sunlight, which is crucial as a source of power. Now, take a look at the pink dots on that same map. They represent possible epicenters of the strongest moonquakes recorded by the Apollo missions. That means that thrust faults in the area could be relatively young and potentially active, representing a real danger to the Artemis 3 crew. These astronauts will journey to lunar orbit over the course of 30 days, and 2 crew members will descend to the surface, spending about a week at the South Pole. Their moonwalk will be particularly challenging, given the extreme temperatures of these permanently shadowed regions. The presence of moonquakes and possible landslides only adds more danger to this mission, as this phenomenon is far more frightening than earthquakes. The strongest moonquake ever recorded had a magnitude of 5.7. You might think that's not a big deal, considering that countries like Chile, Colombia, and Papua New Guinea experienced earthquakes of similar magnitude in 2023 without significant damage. But the gravitational pull on the moon is relatively weaker than on Earth, so what feels like a gentle tremor on our planet might be a real ground-shaking event up there. This happens because you're not as firmly connected to the surface of the moon as you are on Earth, meaning that seismic waves can cause the surface to move more freely. There's also a huge difference in duration. Earthquakes typically last between 10 and 30 seconds, with some lasting up to 2 minutes. A moonquake can persist much longer than that. Our satellite is essentially a solid, rigid, and dry sphere. So when a tremor shakes the moon's surface, it resonates powerfully without any natural means of dissipation. Moonquakes can last for a good 10 minutes or even longer, with little tremors sticking around for hours afterwards. Now, these new findings about shallow moonquakes won't actually change the potential landing sites for Artemis 3, and they won't affect the duration of the mission either. That's because accurately estimating how often a specific region experiences these tremors is tricky and unpredictable. What scientists do know is that these shallow quakes aren't very common and pose a low risk to short-term missions on the lunar surface. But that situation changes completely if we consider long-term habitation on the moon, and that could happen sooner than we expect. The Artemis 3 mission represents an important first step towards space colonization. China is also making the first moves to establish a permanent lunar base at the South Pole by 2040. Their strategy involves utilizing 3D printing and brick production from lunar soil for constructing the moon base. That definitely sounds fascinating, but putting together a setup like that comes with a bunch of challenges, including dealing with intense cosmic radiation, the lack of water, and of course, long-lasting moonquakes. Over billions of years, the surface of the moon has been hit by asteroids and comets, causing bits and pieces to constantly break off from the impacts. Because of this, all the surface material is pretty loosely packed, so when there are quakes, slopes in the same area can become susceptible to landslides or new faults opening up. Future settlements located too close to these unstable slopes could put everyone living inside these lunar bases at risk. Moon dust adds another layer of complexity because, without erosion or water to smooth it out, it can harden to the point of being as tough as glass. If we really want to understand how dangerous moonquakes might be for people living and working on the moon in the future, space agencies still need to map out and get new seismic data, and not just from the South Pole, but from the entire satellite. In 2025, the Farside Seismic Sweep Mission, or FSS, plans to deploy two of the most high-precision seismometers ever built to the Schrödinger crater, which is located on the dark side of the moon. Finding out what's happening on the ground there is crucial for understanding the complex lunar structure and its internal dynamics. Scientists are still trying to figure out whether the lack of recorded seismic activity on the far side of the moon is due to current instruments not being capable of detecting it, or if it's due to some kind of interference from melted material in the mantle. Once they have this answer, it will be easier to fully understand the phenomenon of shallow moonquakes and assess their implications for future neighborhoods on our natural satellite. Now, you may have heard that Earth is also shrinking, but it's a different process. Basically, the moon is getting smaller mainly because its core is cooling down naturally. The Earth's core is cooling too, but our planet got its crust with tectonic plates, unlike the moon, which only has one plate. So the energy from Earth's core shifts those plates around or comes through volcanic eruptions. Earth is actually losing mass overall due to atmospheric loss. Our planet loses about 100 million pounds of mass per year, mostly from a leaky atmosphere. Earth's gravity isn't strong enough to retain the lightest particles, like hydrogen and helium, which escape into space. But don't worry, these numbers aren't cause for alarm, considering that our planet's atmosphere weighs about 5 quadrillion tons, a number I can't even imagine. So, in other words, it would take many times the current age of the universe for it to completely evaporate. Well, that makes me breathe easier. How about you? Pluto used to be considered a major planet, but later was reclassified into something called a dwarf planet. Something too big to be an asteroid, but too small to be taken seriously. How rude. But recently, scientists began to discuss the mystery surrounding one of Pluto's moons. It turns out it might be even cooler than all of us. It might be a double planet system. Pluto is residing in the distant Kuiper Belt. It's a vast area in our solar system, like a big rocky suburb beyond the orbit of Neptune. It's filled with small icy objects, similar to Pluto, called Kuiper objects. They're leftovers from the early days of our solar system and give us clues about how it was formed. It's where many comets come from. You already know that it's small, but it's remarkable just how small it is. Pluto has a width of about 1,400 miles. It's about half the size of the United States and smaller than our moon. Pluto's atmosphere is very thin and composed of nitrogen, methane, and carbon monoxide. Stinky. It's also very cold there, with average temperatures being around minus 390 degrees Fahrenheit. Its orbit around the Sun looks like an oval, and 1 year on Pluto takes around 250 Earth years. Pluto also shows a strange and unusual retrograde rotation because it's tilted on its axis, which means that it spins on its side. If you were standing on Pluto, you'd see a lot of high icy mountains, valleys, plains, and craters. The Sun would be very dim and far away, and it would always look like twilight. It's a colorful planet, surprisingly. You would see a rainbow of pale blues, yellows, oranges, and deep reds. And the most adorable fact about Pluto is its famous heart, called Tombaugh Regio. Pluto was discovered super late in the 1930s, later than the rest of the planets. Initially, we thought that it's the 9th planet in our solar system. However, the more we explored the Kuiper Belt, the more we realized that it's full of these medium-sized objects. We found 4 more little planets just like Pluto: Eris, Ceres, Makemake, and Haumea. They all shared the same characteristics, and that's where we figured out that Pluto belongs to another family and created a category of dwarf planets. There are a couple of differences between these two categories. The first obvious difference is size and mass. Major planets are much bigger and more massive. They also have to be spherical, while dwarf planets might not be perfect spheres and might have weird shapes, like an egg-shaped Haumea, for example. And just like a regular planet, a dwarf planet orbits the Sun, but it doesn't have a clear orbit. Its orbit is full of debris and random objects. These are the only differences between the two. Well, as you can imagine, the reclassification sparked quite a controversy. People even made up a new term, Plutoed, which means downgraded. But although it might be sad that Pluto isn't a major planet anymore, we can look at it like a story about finding your true family. And finally, while standing on Pluto, you would see its 5 moons: Styx, Nix, Kerberos, Hydra, and the most mysterious one, Chiron, also pronounced Charon. So you can pronounce it however you like. I'm going to go with Charon. Now Charon is Pluto's largest moon. It was discovered in the 70s thanks to NASA's spacecraft called New Horizons. The spacecraft took a picture that revealed a moon with a strange and fascinating huge red-brown spot on its surface. It's a vast canyon dwarfing the Grand Canyon. It seems that both Pluto and its moon can boast interesting formations on their surface. The thing about Charon is that it's very big for a moon. It's about half the size of Pluto. This makes scientists wonder, could it be that Pluto is a double planet system? The center of mass, or barycenter, of Pluto and Charon lie outside of Pluto. Normally, with planets and their moons, the center of the planet itself should be the center of the mass, with the moon orbiting around it. But in the case of these two, it seems like they orbit each other. Binary objects are quite common in the universe. These cosmic pairs form just like our moon, from giant impact events. But double planets are exceedingly rare, and we haven't discovered any double dwarf planets yet. So, if it's true, then Charon is actually the 6th dwarf planet, and that would be our first binary dwarf planet system ever. There's also another candidate, the dwarf planet Eris and its moon Dysnomia. The solar system is full of mysterious and fascinating moons, so fascinating that some of them might not even have actual life on them. We've been talking about microscopic life in space for a while now. The debates about whether we found some organic fossils on Mars or not have been going on for decades. With the development of our technology, we're finally getting onto something. Meet Enceladus, who has stolen the spotlight since NASA's Cassini probe arrived there. Enceladus is covered in a sort of snowy blanket, which is why it's so unusually bright and has some snow-covered craters. It's small, only about 310 miles, and is mostly composed of simple rock and ice. But in 2004, we found plumes of water bursting out from this moon's south pole, which means that there's liquid water beneath this moon's icy surface. It's probably because of Saturn and its other larger moon, Dione. Their gravitational dance creates tidal forces that keeps Enceladus warm and lively. All this means that Enceladus is now a top candidate in the search for life within our solar system. Of course, life requires more than just water, and we won't find any animals there or anything like that. But we might find some microscopic organisms, and that's awesome too. In fact, Saturn is winning the lottery when it comes to life candidates. For example, scientists have a wild idea that Titan, another of its moons, might be home to extraterrestrial life as well. Titan is a frosty moon, chilling at about minus 290 degrees Fahrenheit. Surprisingly, it has some lakes on its surface. But don't imagine your typical water bodies. These lakes are believed to be filled not with water, but with liquid ethane or methane. Back in 2005, NASA discussed that there might be life munching on chemicals like acetylene or hydrogen in Titan's lakes. And then, in 2010, NASA investigated this moon some more. They found missing hydrogen and acetylene on Titan's surface, hinting at the possibility of something eating away at these substances. That's why some scientists dare to imagine methane-eating beings in Titan's freezing lakes. Moreover, they suggested that if these creatures exist, they probably have much larger cells than animals on Earth. What we could find there is something much bigger than a simple microbe, even something like a small animal. But Saturn isn't the only lucky one. Triton is Neptune's biggest moon. And you guessed it, it's another life candidate. It's an icy world with frozen nitrogen all over its surface and a crust made of water ice, again super chilly. However, Triton is a hotspot for geologists because it's one of just 5 moons in our solar system that likes to show off with its active geysers. It's shooting nitrogen gas up into space. That would be a cool show, if we could see that. These geysers mean that Triton has some secret source of warmth, which means that, just like with Enceladus, there might be some liquid water underground on Triton. And if this cozy spot for life does exist, we might find some organics there. Unfortunately, sending a mission to explore these celestial bodies isn't easy. The only spacecraft we've sent so far was our Voyager 2 in 1989. We need more time, money, and technology to develop spacecrafts that would be able to travel far and investigate the area beyond Mars. And even if we do, it'll take decades for this spacecraft to reach these places. In any case, let's hope that during the 21st century, we'll finally be able to fully explore our solar system and all its mysteries.